December 15th, 1944, 11:47 p.m. Compound 7 of the Allied Prisoner Processing Center, Hollandia, New Guinea. Lieutenant Commander Hiroshi Yamamoto, of the Imperial Japanese Navy's 4th Submarine Squadron, stumbled through the wooden doorway of Barracks Block C, his legs trembling from 3 days without food, and the shock of capture after his I-class submarine was depth-charged into surrender off the coast of Barracks Island. What he witnessed in that moment defied every piece of intelligence briefing, every propaganda report, and every assumption about Allied capabilities that had been drilled into him during 2 years of Pacific warfare. The entire interior of the massive wooden structure blazed with brilliant white light, as bright as midday sunshine, emanating from dozens of glass bulbs suspended from the ceiling by electrical cables that snaked across the rafters like mechanical vines. His pupils, dilated from days in the darkness of his sinking submarine and the jungle trek to captivity, contracted painfully as he raised his hands to shield his eyes from an illumination so intense and uniform that it seemed to transform night into day with the simple flip of a switch. For 28 months, Yamamoto had commanded submarine patrols in waters where Japanese forces rationed every drop of fuel, every round of ammunition, and every scrap of metal with the desperation of men who knew their supply lines were cut. His own submarine had operated for the final 6 months with emergency lighting only, using candles and oil lamps to preserve the failing electrical systems that couldn't be repaired without parts that would never come. The brass in Tokyo had assured him that American forces were equally desperate, equally starved of resources, fighting a war across an ocean that stretched their capabilities beyond breaking point. Yet here, in what appeared to be a hastily constructed prisoner facility in the middle of a jungle on a remote Pacific island, the enemy was burning enough electricity to power a small Japanese city, illuminating their captives with casual abundance that spoke of resources so vast they could afford to waste power on the comfort of defeated enemies. The cognitive dissonance hit him like a physical blow, causing his knees to buckle as other captured Japanese personnel around him stood frozen in similar shock, their faces pale in the harsh electric glare that revealed the terrible truth about which side was truly winning this war. What Yamamoto discovered in those crucial minutes would shatter not just his understanding of the Pacific conflict, but reveal a technological and industrial gap so vast that it rendered Japanese resistance not heroic, but mathematically impossible. The technology he witnessed had been standard equipment in American military installations for over 2 years, mass-produced by companies like General Electric and Westinghouse at a rate that would have seemed like science fiction to Japanese military planners who were melting down temple bells to make bullets. For 37 years, Yamamoto had believed in the spiritual superiority of Japanese warriors, the efficiency of Japanese engineering, and the inevitable victory that would come through superior dedication and sacrifice. This moment marked the beginning of a psychological collapse that would sweep through Japanese prisoner-of-war camps across the Pacific, as captured personnel encountered evidence of American industrial capacity that made their own nation's war effort appear primitive by comparison. The electrical system illuminating Barracks Block C represented just one small component of a logistics network that dwarfed anything in Japanese military experience. Technical Sergeant James Morrison of the 503rd Electrical Construction Battalion had supervised the installation of the lighting system in just 4 days, using prefabricated components shipped directly from General Electric's manufacturing facility in Schenectady, New York. The power came from 3 diesel generators, each capable of producing 150 kilowatts of electricity, burning high-grade fuel that arrived weekly on Liberty ships, carrying 10,000 tons of supplies to support the Hollandia base complex. Morrison's unit had electrified 17 similar compounds across New Guinea in the past month alone, following standardized procedures that treated electric lighting in prisoner facilities as a basic humanitarian requirement rather than a luxury. The American military had calculated that proper lighting reduced guard requirements, prevented escape attempts, and improved prisoner health and morale, making electric illumination not just feasible but strategically necessary in their comprehensive approach to managing captured enemy personnel. Yamamoto's fellow prisoners began emerging from their initial shock to examine the electrical fixtures with the fascination of men encountering alien technology. Petty Officer Kenji Nakamura, an electrician aboard the destroyer Yukikaze, before his ship was sunk during the Philippine Sea battle, ran his fingers along the insulated copper wiring with reverence bordering on worship. The gauge of the wire, the quality of the insulation, the precision of the electrical connections represented manufacturing standards that exceeded anything he had seen in Japanese naval vessels, even in the flagship installations of the combined fleet. Each light bulb bore the marking D100W stamped into the glass, indicating not only the manufacturer but the precise wattage rating, a level of standardization that spoke to mass production on an almost incomprehensible scale. Nakamura had spent the final months of his service cannibalizing electrical systems from damaged ships to keep essential equipment functioning, using hand-twisted wire connections and improvised repairs that reflected the desperate shortage of proper electrical components throughout the Japanese military. The casual abundance displayed in this prison barracks suggested that Americans were manufacturing electrical equipment at rates that exceeded Japanese production capacity by orders of magnitude. The psychological impact deepened as prisoners began to notice details that revealed the systematic nature of American logistics superiority. The diesel generators powering the electrical system ran continuously, their steady hum providing a mechanical soundtrack to conversations conducted in the shocked whispers of men whose worldview was crumbling in real time. Sergeant Morrison mentioned during his daily inspection that the generators consumed approximately 50 gallons of fuel per day, a quantity that would have powered a Japanese patrol boat for a week of combat operations. Yet here it was being burned simply to keep lights on in buildings housing enemy prisoners, with fuel deliveries scheduled so regularly that Morrison never bothered to check supply levels. The American military treated diesel fuel with the same casual abundance that Japanese forces reserved for drinking water, burning petroleum products for comfort and convenience, while Japanese commanders were rationing fuel for critical combat missions and watching their most experienced pilots die in training accidents caused by inadequate flight time. December 16, 1944, 6:15 a.m. Compound 7 Mess Hall, Hollandia. The electric lights remained blazing as dawn broke over the New Guinea jungle, creating an artificial daylight that eliminated the gradual transition from night to morning that had governed human activity for millennia. Captain Sato Ishikawa, of the Japanese Army's 18th Infantry Division, watched American guards flip switches to turn off sections of the lighting system as natural sunlight began filtering through the mess hall windows, a gesture so casual and routine that it emphasized the unlimited nature of the power supply. Ishikawa had commanded infantry units that fought by moonlight and candlelight, preserving every battery and every drop of lamp oil for critical operations, while American forces apparently possessed sufficient electrical generating capacity to illuminate their facilities 24 hours a day. The switch-flipping ritual fascinated the Japanese prisoners, who gathered each morning to watch guards control artificial sunlight with the casual gesture of men who had never known energy scarcity. The mess hall lighting system revealed additional layers of American technological superiority that went far beyond simple illumination. The electrical infrastructure included ventilation fans that circulated air throughout the building, preventing the accumulation of cooking odors and humidity that plagued Japanese military facilities. Refrigeration units hummed quietly in the kitchen area, preserving fresh meat and dairy products that arrived weekly on supply ships that never seemed to face shortages or delays. Electric water pumps provided hot and cold running water to washing stations that remained operational throughout the day, consuming energy and water with an abundance that shocked prisoners who had grown accustomed to cold water rationing and infrequent bathing opportunities. The Americans had created a mechanical environment that eliminated most of the basic hardships that Japanese forces accepted as inevitable aspects of military life, using technology and resources to solve problems that Japanese commanders addressed through discipline and endurance. The breakfast service provided the most devastating evidence yet of the resource disparity between American and Japanese forces. Electric griddles and warming plates kept food at optimal serving temperature throughout the meal period, while electric mixers and food processors in the kitchen reduced food preparation time and improved meal quality beyond anything available to Japanese military personnel. The prisoners received portions of eggs, bacon, fresh bread, and coffee that exceeded the daily rations allocated to Japanese combat units fighting in the Philippines, served on metal trays that would have been melted down for ammunition in any Japanese facility. Electric dishwashers cleaned hundreds of plates and utensils after each meal, using heated water and mechanical agitation that eliminated the manual labor typically required for food service cleanup. The casual waste of electricity for cleaning dishes struck Japanese prisoners as profoundly decadent, representing energy expenditure that could have powered essential military equipment in their own forces. Ishikawa began calculating the resource implications of what he was witnessing, applying the mathematical training that had made him an effective logistics officer before his capture during the Battle for Leyte. The electrical consumption of Compound 7 alone exceeded the power generation capacity of most Japanese military bases. Yet this facility represented just one small component of the Hollandia complex that housed thousands of Allied personnel and processed hundreds of prisoners monthly. If Americans could afford to electrify prisoner-of-war facilities with the same casual abundance they applied to their own military installations, their total industrial capacity must exceed Japanese production by factors that made continued resistance mathematically impossible. The numbers told a story that contradicted every briefing he had received about American war weariness and resource limitations. American forces were not struggling to maintain their Pacific offensive. They were operating with such overwhelming material superiority that they could afford to provide their enemies with living conditions that exceeded what Japanese soldiers experienced in their own barracks. December 17, 1944, 2:30 p.m., Compound 7 Medical Facility, Hollandia. The electric lighting in the medical barracks operated at intensity levels that transformed routine medical examinations into procedures that would have required surgical theater conditions in Japanese facilities. Takeshi Yamada, former chief medical officer of the 14th Army Field Hospital, stood blinking in artificial illumination so bright and uniform that it eliminated shadows and provided perfect visibility for detailed medical work at any hour of the day or night. The American medical staff performed routine health screenings under lighting conditions that exceeded what he had available for emergency surgery in Japanese field hospitals, using electricity with such casual abundance that examination rooms remained fully illuminated even when unoccupied. Yamada had performed amputations and treated critical wounds by candlelight and oil lamp, rationing every moment of battery-powered illumination for the most crucial procedures, while American medics enjoyed perfect lighting conditions for routine prisoner processing. The medical equipment revealed technological capabilities that made Japanese military medicine appear medieval by comparison. Electric X-ray machines provided instant diagnostic imaging that eliminated the guesswork and delays that characterized medical treatment in Japanese forces, while electric sterilization equipment maintained surgical instruments at hospital standards throughout the day. Electric water heating systems provided unlimited hot water for sterilization and cleaning, contrasting sharply with the cold water rinses and alcohol rationing that compromised medical sanitation in Japanese field hospitals. Electric refrigeration preserved medicines and blood supplies that would have spoiled within hours in tropical conditions, allowing American medical staff to maintain pharmaceutical inventories that exceeded the total medical supplies available to entire Japanese divisions. The systematic application of electrical power to medical support created treatment capabilities that would have seemed miraculous to Japanese medical personnel accustomed to working with hand tools and limited supplies. The psychological impact on Japanese medical personnel proved particularly devastating, because their professional training allowed them to understand the full implications of what they were witnessing. Lieutenant Nurse Michiko Tanaka of the Imperial Army Nursing Corps recognized that the electric sterilization equipment alone represented manufacturing and resource allocation that exceeded Japan's total medical technology production capacity. The quality of the electrical wiring, the precision of the power regulation, and the reliability of the electrical supply indicated industrial capabilities that could mass-produce medical equipment while simultaneously supporting massive military operations across multiple theaters of war. Tanaka had watched Japanese field hospitals cannibalize equipment from captured facilities and improvise medical tools from battlefield scrap, while American forces apparently possessed sufficient industrial capacity to equip prisoner medical facilities with technology that exceeded what Japanese military hospitals had available for their own wounded personnel. The American medical staff mentioned casually that the electrical equipment in the prisoner facility represented standard issue for military medical units manufactured by companies like General Electric Medical and Westinghouse Healthcare in quantities sufficient to supply Allied forces worldwide. The routine nature of this advanced medical technology shocked Japanese medical personnel who had trained in facilities where electric lighting was intermittent and electric medical equipment was virtually non-existent. Yamada calculated that the electrical consumption of the prisoner medical facility alone exceeded the power requirements of the largest Japanese military hospital, yet American forces were deploying this technology in temporary facilities designed to process captured enemy personnel. The mathematical implications were staggering. If Americans could afford to provide captured enemies with medical technology that exceeded what Japanese forces could provide their own wounded, the industrial capacity gap was so vast that Japanese military resistance was essentially meaningless. December 18, 1944, 7:45 p.m., Compound 7 Recreation Barracks, Hollandia. The evening illumination of the recreation facility provided Japanese prisoners with their first exposure to electric lighting, used purely for entertainment and morale purposes, rather than essential military functions. Master Sergeant Koji Watanabe of the Imperial Army Engineers watched American guards activate banks of electric lights that transformed the recreation barracks into a brightly lit social space where prisoners could read, write letters, and engage in conversation during evening hours that would have been spent in darkness in any Japanese military facility. The casual use of electricity for prisoner recreation struck Watanabe as almost incomprehensibly wasteful, representing energy expenditure that served no military purpose beyond maintaining the psychological well-being of captured enemy personnel. Japanese forces had eliminated recreational electricity consumption months earlier, redirecting all available power to essential military systems, while American forces apparently possessed such abundant electrical capacity that they could afford to illuminate enemy prisoners for entertainment purposes. The recreation barracks contained electric fans that provided air circulation for prisoner comfort, electric heaters that maintained optimal temperature during cool jungle evenings, and electric outlets that powered radios broadcasting American news programs and popular music. The systematic application of electrical power to prisoner comfort revealed resource allocation priorities that would have been considered treasonous in Japanese military culture, where any energy not devoted to combat effectiveness was viewed as a betrayal of national sacrifice. Yet American forces had calculated that maintaining prisoner morale through electrical amenities reduced security requirements and improved intelligence gathering, making recreational electricity consumption a strategic investment rather than frivolous waste. The mathematical efficiency of American resource allocation impressed Japanese prisoners even as it demonstrated the hopeless inadequacy of their own military's approach to logistics and personnel management. The electric radios provided the most psychologically devastating revelation yet about American industrial and technological capabilities. The radio broadcasts included detailed reports about American bomber production rates, steel manufacturing statistics, and military deployment figures that would have been classified information in Japanese forces, but were apparently considered suitable for public consumption in American society. Japanese prisoners learned that American factories were producing over 3,000 military aircraft monthly, while Japanese production had dropped below 500 aircraft per month due to material shortages and bombing damage to manufacturing facilities. The radio programs mentioned casually that American electrical generating capacity had increased by 40% since the beginning of the war, providing the industrial foundation for military production rates that exceeded Japanese capabilities by factors that made continued resistance mathematically impossible. The Americans were not struggling to maintain their war effort. They were operating with such overwhelming industrial superiority that they could afford to inform their enemies about production statistics that demonstrated Japanese defeat was inevitable. Watanabe began experiencing the physical symptoms of psychological collapse that would become common among Japanese prisoners as they processed the implications of American resource abundance. Sleeplessness, trembling hands, and digestive problems reflected the stress of confronting evidence that contradicted everything he had believed about Japanese military effectiveness and American industrial limitations. His identity as a proud member of the Imperial Army Engineer Corps had been built on assumptions about Japanese technological and spiritual superiority that crumbled when confronted with electric lighting systems that exceeded Japanese engineering capabilities and revealed American industrial capacity that dwarfed Japanese military production. The casual abundance of electricity in a prisoner facility demonstrated that American forces were not being stretched to their limits by Pacific warfare. They were operating with such overwhelming material advantages that they could afford to provide their enemies with technological amenities that exceeded what Japanese soldiers received in their own facilities. December 19, 1944, 4:20 a.m. Compound 7 Communications Center, Hollandia. The pre-dawn activation of the communications facility's lighting system provided Japanese prisoners with their first glimpse of American military communications technology and the electrical infrastructure required to support global military coordination. Colonel Masahiko Fukuda of the Imperial Army Signal Corps watched American communications specialists activate banks of electric lights that illuminated radio equipment, telephone switchboards, and telegraph systems that maintained continuous contact with Allied forces across the Pacific Theater. The communications center operated 24 hours a day, with electrical consumption that exceeded the power requirements of entire Japanese military divisions, using electricity to maintain real-time coordination between Allied forces separated by thousands of miles of ocean. Fukuda had commanded signal units that rationed battery power for critical communications and used oil lamps for equipment maintenance, while American forces apparently possessed sufficient electrical generating capacity to maintain continuous global communications networks. The scale and sophistication of American communications equipment revealed technological capabilities that made Japanese military communications appear primitive by comparison. Electric teletype machines transmitted written messages instantaneously across thousands of miles, while electric amplification systems boosted radio signals to penetrate atmospheric interference that blocked Japanese communications attempts. Electric power supplies maintained vacuum tube radio equipment that provided clear voice communications with Allied units throughout the Pacific, contrasting sharply with the static-filled intermittent communications that characterized Japanese military radio networks. Electric cooling systems prevented communications equipment from overheating in tropical conditions, allowing American forces to maintain reliable communications while Japanese signal units watched their equipment fail due to heat damage and inadequate power supplies. The systematic application of electrical power to communications support created coordination capabilities that gave American forces overwhelming tactical and strategic advantages over Japanese units that often operated without reliable contact with higher headquarters. The communications specialists mentioned that the electrical equipment in the prisoner facility communications center represented standard issue for Allied military units, manufactured by companies like RCA and Motorola in quantities sufficient to supply global military operations. The routine nature of this advanced communications technology shocked Japanese signal personnel who had trained on equipment where electric power was intermittent, and electric communications devices were considered specialized tools reserved for the most critical operations. Colonel Fukuda calculated that the electrical consumption of the prisoner facility communications center alone exceeded the power generation capacity of most Japanese military headquarters. Yet, American forces were deploying this technology in temporary facilities designed to coordinate prisoner processing activities. The mathematical implications were devastating. If Americans could afford to provide prisoner facilities with communications technology that exceeded what Japanese forces could provide their own command centers, the technological capacity gap was so vast that Japanese military coordination was hopelessly inferior. The American communications networks included direct telephone connections to Allied headquarters in Australia, the Philippines, and Hawaii, maintained through electrical amplification systems that boosted signal strength across underwater cables and radio relay stations. Japanese communications personnel had spent months trying to establish reliable contact with their own headquarters units, while American forces maintained continuous real-time communications with Allied forces across multiple continents. The electric power requirements for maintaining these global communications networks exceeded the total electrical generating capacity of the Japanese military, yet American forces treated international communications as routine administrative support rather than critical military capability. The psychological impact on Japanese signal personnel was profound as they realized that American forces possessed communications advantages so overwhelming that Japanese military coordination was essentially blind and deaf compared to Allied information networks. December 20th, 1944, 10:15 a.m. Compound 7 Workshop Facility, Hollandia. The workshop barracks revealed the most devastating evidence yet of American industrial and technological superiority through the casual deployment of electric power tools and manufacturing equipment for routine maintenance and repair operations. Chief Petty Officer Hiroshi Yamashita of the Imperial Navy Construction Battalion watched American technical personnel use electric drills, electric saws, electric welding equipment, and electric grinding tools to perform maintenance tasks that would have required hours of manual labor in Japanese facilities. The workshop consumed enough electricity to power a small Japanese city while producing repairs and modifications that exceeded the capabilities of most Japanese military manufacturing facilities. Yamashita had supervised construction projects using hand tools and muscle power, while American forces apparently possessed sufficient electrical generating capacity to mechanize routine maintenance tasks that Japanese personnel performed through physical labor and primitive equipment. The quality and quantity of electric power tools in the workshop represented manufacturing capabilities that dwarfed Japanese industrial production and revealed the technological foundation underlying American military effectiveness. Electric motors powered precision drilling equipment that produced parts with tolerances that exceeded Japanese manufacturing standards, while electric welding systems created metal joints stronger and more reliable than anything achievable with Japanese welding technology. Electric grinding and polishing equipment produced surface finishes that would have required days of hand labor in Japanese facilities, completed in minutes through mechanical precision that eliminated human error and inconsistency. Electric lighting provided perfect visibility for detailed mechanical work at any hour, allowing American technical personnel to maintain productivity schedules that would have been impossible in Japanese facilities dependent on natural lighting and oil lamps. The electric power supply for the workshop included voltage regulation equipment that maintained consistent electrical characteristics regardless of load variations, protecting sensitive equipment and ensuring reliable operation of precision tools. Japanese facilities had experienced frequent equipment failures due to voltage fluctuations and inadequate power supplies, while American forces deployed electrical infrastructure that maintained industrial quality power standards in temporary military installations. The electric generators supporting the workshop facility included automatic load balancing systems that adjusted power distribution based on equipment requirements, representing electrical engineering sophistication that exceeded anything in Japanese military experience. The systematic application of electrical power to routine maintenance tasks created productivity advantages that allowed American forces to maintain equipment effectiveness while Japanese units watched their gear deteriorate due to inadequate repair capabilities. Yamashita began calculating the productivity implications of mechanized maintenance and repair capabilities powered by abundant electrical supply. American technical personnel completed in one-day maintenance tasks that would require Japanese crews a full week using hand tools and manual labor, multiplying effective workforce productivity by factors that made American logistics support overwhelmingly superior. The electric power tools eliminated the physical fatigue that limited Japanese maintenance schedules while providing precision and reliability that exceeded human capabilities. The mathematical efficiency of electric-powered maintenance created equipment readiness rates that allowed American forces to maintain combat effectiveness while Japanese units operated with deteriorating equipment and declining mechanical reliability. The workshop facility demonstrated that American military superiority was not just about having more equipment, but about having industrial infrastructure that could maintain and repair equipment at rates that kept American forces operating at peak effectiveness while Japanese capabilities steadily declined. December 21st, 1944, 8:30 p.m. Compound 7 Administrative Offices, Hollandia. The evening shift in the administrative facility provided Japanese prisoners with their first exposure to American military bureaucracy, powered by electric office equipment that mechanized paperwork and record-keeping tasks. Lieutenant Colonel Kentaro Nakamura, of the Imperial Army General Staff, watched American administrative personnel use electric typewriters, electric adding machines, electric filing systems, and electric duplicating equipment to process prisoner documentation with speed and accuracy that exceeded anything in Japanese military administration. The administrative offices consumed electricity for lighting, equipment operation, and environmental control that would have powered an entire Japanese regimental headquarters, while producing paperwork processing capabilities that dwarfed Japanese administrative capacity. Nakamura had supervised headquarters units that processed documents by hand and oil lamp, while American forces apparently possessed sufficient electrical infrastructure to mechanize routine administrative tasks. The electric office equipment revealed systematic approaches to military administration that multiplied American organizational effectiveness through technological advantage. Electric typewriters produced documents with uniform formatting and legibility that eliminated the inconsistencies and errors that plagued handwritten Japanese military paperwork, while electric adding machines performed mathematical calculations with speed and accuracy that exceeded human capabilities. Electric duplicating equipment produced multiple copies of orders and reports instantly, allowing American forces to distribute information simultaneously to multiple units, while Japanese forces relied on hand-copied documents that introduced delays and transcription errors. Electric filing systems included motorized document retrieval that located specific records in seconds rather than the hours required for manual file searches in Japanese administrative systems. The scale of American administrative operations revealed organizational capabilities that reflected overwhelming resource advantages over Japanese military bureaucracy. The administrative offices processed prisoner documentation for thousands of captured personnel using electric equipment that maintained detailed records, medical histories, interrogation reports, and correspondence with accuracy that would have been impossible using Japanese administrative methods. Electric communications equipment allowed administrative personnel to coordinate with higher headquarters, intelligence units, and logistics commands in real time, creating information flow that kept American forces synchronized and responsive, while Japanese units often operated with outdated information and delayed orders. The mathematical efficiency of electric-powered administration created organizational advantages that allowed American forces to coordinate complex military operations while Japanese forces struggled with communication delays and administrative bottlenecks. The psychological impact on Japanese administrative personnel reflected the broader pattern of ideological collapse that swept through prisoner compounds as captured military personnel confronted evidence of American technological and industrial superiority. Lieutenant Colonel Nakamura experienced sleepless nights, loss of appetite, and trembling hands as he processed the implications of administrative mechanization that revealed American organizational capacity exceeding Japanese capabilities by orders of magnitude. His professional identity had been built on pride in Japanese military efficiency and administrative precision, assumptions that crumbled when confronted with electric office equipment that performed administrative tasks faster and more accurately than human Japanese clerks. The casual abundance of electricity for administrative purposes demonstrated that American forces were not straining to support their Pacific operations. They were operating with such overwhelming resource advantages that they could afford to mechanize routine paperwork tasks that Japanese forces performed through manual labor and primitive equipment. December 22, 1944, 11:45 p.m. Compound 7 Security Perimeter, Hollandia. The nighttime illumination of the prison compound's security perimeter provided the most psychologically devastating demonstration yet of American resource abundance and technological superiority. Captain Jiro Matsumoto of the Imperial Army Military Police watched American guards activate floodlights that transformed the jungle darkness into artificial daylight, extending hundreds of yards beyond the compound boundaries. The security lighting system consumed enough electricity to illuminate a Japanese city while providing surveillance capabilities that made escape attempts virtually impossible and demonstrated American ability to control their environment through technological dominance rather than human manpower. Matsumoto had commanded security units that relied on manual patrols and limited lighting, while American forces apparently possessed sufficient electrical generating capacity to eliminate darkness as a tactical factor in prisoner security operations. The sophistication of the electrical security systems revealed technological applications that exceeded anything in Japanese military experience and demonstrated systematic approaches to using industrial capacity for military advantage. Electric motion sensors triggered automatic lighting responses that illuminated potential escape routes before human guards could respond, while electric alarm systems provided instant notification of security breaches throughout the compound. Electric communications networks allowed security personnel to coordinate responses immediately, creating reaction capabilities that eliminated the delays and confusion that characterized Japanese security operations. Electric power supplies maintained security equipment operation throughout the night, providing consistent surveillance effectiveness while Japanese security forces experienced equipment failures and power shortages that created vulnerabilities in their defensive systems. The security perimeter included electric fencing systems that delivered non-lethal but incapacitating electrical shocks to anyone attempting unauthorized contact, representing electrical engineering applications that would have seemed like science fiction to Japanese military personnel, accustomed to using barbed wire and manual barriers. The electric power requirements for maintaining the security systems exceeded the total electrical generating capacity available to most Japanese military installations, yet American forces deployed this technology routinely in temporary prisoner facilities without apparent concern about energy consumption or equipment availability. The mathematical implications were staggering. If Americans could afford to electrify prisoner security systems with technology that exceeded Japanese capabilities, their industrial and electrical generating capacity was so vast that Japanese resistance was meaningless against such overwhelming technological advantages. The psychological breakdown among Japanese security personnel reflected the broader pattern of ideological collapse that occurred when professional military officers confronted evidence that their entire understanding of warfare and industrial capacity was fundamentally incorrect. Captain Matsumoto experienced physical illness, disorientation, and depression as he realized that American forces possessed technological capabilities that made Japanese military resistance not heroic but futile. His professional training had emphasized Japanese spiritual superiority and tactical excellence as factors that would overcome American material advantages, assumptions that crumbled when confronted with security technology that eliminated human skill and determination as relevant factors in military effectiveness. The casual deployment of electric security systems demonstrated that American forces were not struggling to contain Japanese prisoners. They were operating with such overwhelming technological superiority that they could afford to automate security tasks that required intensive human labor in Japanese facilities. December 23, 1944, 6 a.m., Compound 7 Central Power Plant, Hollandia. The dawn tour of the electrical generating facility provided Japanese prisoners with their most complete understanding of American industrial and technological capabilities through direct observation of the power systems that supported the entire compound complex. Chief Engineer Takeshi Suzuki of the Imperial Navy Construction Corps watched American power plant operators manage 3 massive diesel generators that produced more electrical power than the largest Japanese military installation, while running continuously with mechanical reliability that exceeded anything in Japanese engineering experience. The power plant consumed thousands of gallons of high-grade diesel fuel daily, representing petroleum allocation that would have supported an entire Japanese naval squadron for weeks of operations, while American forces burned this fuel simply to maintain electrical power for prisoner facilities. Suzuki had supervised power systems that rationed every kilowatt-hour and struggled to maintain basic electrical service, while American forces apparently possessed unlimited fuel supplies and generating equipment that operated without mechanical problems or supply interruptions. The technical specifications of American generating equipment revealed manufacturing capabilities and engineering standards that dwarfed Japanese industrial production and demonstrated the technological foundation underlying American military effectiveness. Each diesel generator incorporated precision engineering, high-quality materials, and manufacturing tolerances that exceeded the capabilities of Japanese military industry, while electrical control systems maintained voltage and frequency regulation that protected sensitive equipment and ensured reliable power distribution. Electric cooling systems prevented generator overheating in tropical conditions, automatic fuel injection systems optimized combustion efficiency, and electric starting systems eliminated the manual cranking procedures required for Japanese generators. The systematic application of electrical technology to power generation created reliability and efficiency advantages that allowed American forces to maintain consistent electrical service, while Japanese power systems experienced frequent failures and service interruptions. The fuel supply logistics for the power plant revealed resource allocation capabilities that made Japanese military logistics appear primitive and inadequate by comparison. Weekly fuel deliveries arrived on schedule regardless of weather conditions or tactical situations, providing continuous supply security that eliminated the fuel rationing and conservation measures that crippled Japanese electrical operations. American fuel quality standards ensured optimal generator performance, while Japanese forces used contaminated or low-grade fuels that caused equipment damage and reduced operational efficiency. The mathematical scale of fuel consumption for electrical generation exceeded the total petroleum allocation available to most Japanese military units, yet American forces treated generator fuel as a routine logistics requirement rather than a precious strategic resource. The psychological impact on Japanese engineering personnel was devastating as they realized that American industrial capacity was so vast that fuel consumption for prisoner facility electrical generation exceeded Japanese military petroleum budgets. The power plant control systems included electrical monitoring equipment that tracked power generation, load distribution, and equipment performance with precision that would have been impossible using Japanese electrical technology. Electric meters, automatic voltage regulators, and computerized load balancing systems maintained optimal electrical characteristics throughout the compound distribution network, providing power quality that exceeded what Japanese facilities could achieve for their most critical military equipment. American power plant operators monitored electrical systems using instruments and controls that represented manufacturing sophistication beyond Japanese technical capabilities, while maintaining generating equipment through procedures and spare parts availability that ensured continuous operation. The systematic approach to electrical power generation and distribution created infrastructure advantages that supported American military effectiveness, while Japanese forces struggled with power shortages and electrical system failures that limited their operational capabilities. December 24, 1944, 3:15 p.m. Compound 7 Final Assembly, Hollandia. The Christmas Eve gathering of all Japanese prisoners in the main compound provided the culminating psychological impact as hundreds of captured military personnel confronted collectively the full implications of American technological and industrial superiority demonstrated through casual electrical abundance. The massive assembly area blazed with electric lighting that eliminated shadows and provided perfect visibility for the largest gathering of Japanese prisoners since their capture, illuminated by electrical power that exceeded the generating capacity of entire Japanese military districts. Colonel Yoshio Tanaka of the Imperial Army General Staff addressed his fellow prisoners in voices that trembled with the emotional weight of men whose fundamental understanding of reality had been shattered by daily exposure to American resource abundance that rendered Japanese military resistance mathematically meaningless. The electric public address system that amplified Colonel Tanaka's voice throughout the assembly area represented just one more example of American technological capabilities that exceeded Japanese military communications equipment while serving purely administrative functions in a prisoner facility. Electric amplifiers, speakers, and microphones provided clear audio transmission that would have been considered luxury equipment in Japanese military installations, yet American forces deployed this technology routinely for prisoner management activities. The sound quality, volume control, and reliability of the electric audio system demonstrated manufacturing standards and engineering capabilities that reflected industrial capacity devoted to producing advanced technology for routine military support functions. Japanese forces had struggled to maintain basic radio communications, while American forces possessed sufficient technological and industrial resources to provide high-quality audio systems for managing captured enemy personnel. The psychological transformation of Japanese prisoners reached its final stage as military personnel, who had believed in inevitable Japanese victory, confronted mathematical evidence that made continued resistance impossible. The daily exposure to electric lighting, heating, cooling, communications, medical equipment, workshop tools, administrative machinery, security systems, and power generation had revealed American industrial and technological capabilities that exceeded Japanese military capacity by factors that rendered spiritual dedication and tactical skill irrelevant to the war's outcome. Major Kenji Yamamoto of the Imperial Army Artillery Corps calculated that the electrical consumption of one American prisoner compound exceeded the power generation available to entire Japanese army groups, while American forces operated hundreds of similar facilities across the Pacific Theater without apparent strain on their industrial capacity. The fundamental truth, revealed through systematic exposure to American electrical technology, was that Japanese military leaders had committed their nation to a war against industrial and technological capabilities so vast that defeat was inevitable, regardless of Japanese courage, sacrifice, or tactical excellence. The electric lights that had initially shocked Japanese prisoners with their brightness and abundance represented just the visible manifestation of American manufacturing capacity that could produce military equipment, fuel supplies, food, medicine, communications gear, weapons, ammunition, and support infrastructure, at rates that overwhelmed Japanese production by mathematical factors that made resistance futile. Colonel Tanaka's final address to his fellow prisoners acknowledged what every captured Japanese military officer had come to understand through daily confrontation with American technological superiority. They had been fighting a war that was already lost before it began, defeated not by enemy courage or tactical skill, but by industrial and technological capabilities that Japanese intelligence had failed to comprehend, and Japanese leadership had refused to acknowledge. The electric lights burning brightly above their heads on Christmas Eve 1944 illuminated not just a prisoner compound in the New Guinea jungle, but the technological foundation of American victory that made Japanese defeat as inevitable as sunrise, as certain as the flip of an electrical switch that could transform darkness into light with casual abundance, that revealed the true balance of power in a war that had never been as close as Japanese propaganda claimed. This moment of collective realization among Japanese prisoners represented a microcosm of the broader psychological collapse that would sweep through Japanese military forces as the Pacific War reached its final phases, when soldiers and civilians alike confronted the mathematical impossibility of victory against American industrial capacity that could illuminate enemy prisoners with greater electrical abundance than Japanese forces could provide their own personnel. The electric lights in Compound 7 had revealed more than just American technological superiority. They had exposed the fundamental delusion underlying Japanese military strategy and the terrible cost of leadership that had committed a nation to unwinnable war against an industrial democracy whose resource advantages were so overwhelming that they could afford to treat captured enemies better than Japanese forces could treat themselves, burning electricity for prisoner comfort, while Japanese soldiers fought in darkness, maintaining mechanical abundance, while Japanese equipment failed from neglect, demonstrating through casual technological deployment that American victory was not just probable, but as inevitable as the steady hum of diesel generators that never stopped running because fuel supplies never ran short, and mechanical systems never failed due to inadequate maintenance or inferior manufacturing quality that plagued Japanese military equipment throughout the Pacific War.